Here's a couple more difficult problems for solving a log without using an exponential. The first one is actually pretty straightforward, like we've been doing. Your common base is what you need to find first. You have 5 as your base for each. 5 to the first power, so that didn't change. This is 5 to the negative second power, so that becomes negative second power. Everything else stays the same. Equals 5 to the what power gives you 625. That's 5 to the fourth power. Now you have all the common bases, so now you can get rid of the exponent. Remember, on the left-hand side, when you multiply with a common base, you add the exponent. So 3x plus negative 2 times x minus 4, and I'll let you solve the rest on that one. For number 2, this one's a little bit different from what we've done as well, but still you need to make a common base. So 3 is your common base for 3 and 9. That's 3 squared, x minus 2. And then same thing over here, 3 to the what power gives you 1? Well, 3 to the 0th always gives you 1. Now you have your easy equation to solve when you divide with a common base. So over here, in number 1, you added the exponents because you had the common base, and we're multiplying. When you're common base dividing, you instead are going to subtract. So 5x minus your 2 times x minus 2 to get your answer. Again, you'll solve just like you've been doing, and I believe you get x equaling, you can confirm with me on this, I think it's negative 4 over 3. Okay. Number 3 is also very similar, but not a whole lot of a difference. 1 over 6 to the x power, well, that's the same as saying 6 to the negative x power. 36 is 6 squared, so that's squared with your power to a power to give you your... Struggling here. Sorry, folks. For your 3x minus 2. And then you have 6 over here for your x squared. So you got negative x plus, because you're multiplying, 6x minus 4 equals 6x squared. This you just now have a quadratic equation that you would need to solve. It would be, what, 6x minus 5x plus 4 would equal 0, and you'd have to try to solve that quadratic equation, which we're not going to try to do right now. And this final problem is the one that's probably the most important, is the fact that right now, with all these problems, it only works if you have multiplication or division being worked with. As soon as you have this addition here, something's got to change. We can't have any addition to be able to do these log and exponential rules that we've been doing. So we need to get rid of that 12 just with some basic algebra first. Move that 12 over. Now you have 16 on the right-hand side. Everything else still the same. And now you can go through the exact same step to finish this problem off. Now you have all multiplication. Now you can use the same base. The base is not 4, even though 4 squared is 16. 4 to no power gives you 8, so that's no good. So we're going to have to use 2 as our base. So 2 squared for that guy, 2 cubed for the 8, and 2 to the 4th for the right. And again, everything else with your exponents staying the same. So this is 3x minus 1 still, and this is x plus 7 is still. And now you can solve just like you have been doing. So that's the main one I wanted to look at, was this problem right here, where you have to add or subtract that 12 over in this case before you can solve the rest of the problem.